All right. Good morning. I hope you're doing well. Won't be a long video. It'll be more work. We got some programming I want you to do. I hope all is well. We'll hopefully trying to finish up programming the next few lessons of processing. Um, so what we're going to do today is talk a little bit about conditional statements again, but getting the concept of looping, because now you've got sequence, you've gotten Boolean logic or conditional statements, think of it that way, and looping, and you really have got the basic core of programming. So last week we talked about conditional statements, and we talked about the situation where you have two if statements. So for example, when go ahead and pull this up, sorry. So that's okay. So we talked about, for example, if you had the variable box, we defined it as an integer and it would be lowercase I. Box equals 15, 15 assigned to box. If you ran this program right now with the two if statements there, it would test both these cases. So this box is red, box is green. What would you see? Well, I would hope that you would see box is green, because this is true, but it would test for this and it would make that true then, and therefore it would replace and make the box green. Again, this is pseudocode. This isn't real code. It's not really going to do anything. I'm just trying to get you to think about it. If variable's 15, box is 15, it says that's true. Oh, it's red. But then it's going to go down and say it's green. Oh, so it's green. As opposed to this situation. Again, box is 15. If box is 5, box is red. Else if box is 10, box is green, what will happen? Give you a moment to think about that. Okay, it's going to be green. It's never going to be green, excuse me. It's going to be red always. Whereas this one was always green. The past one was always green because that was the last one. This will be red. Why? Because when you test this, it says, oh, that's true. And once it's true, it jumps out to the next bit of code. It never gets down to that second bit of code. So again, that's the power of an else if. They're both if statements, it'll test each statement. Else if, and then a cleanup else are a way of just testing something once. You only get one of those choices. So here's box is blue. Now, again, if it's 15, it's going to be red right off the bat, because is box greater than 10? Yes. But what happens if it's 15? Well, if it's 15, if box is 15, we said that. If box is 10, well, it's no longer greater than 10, so now the box is green. What about 5? Well, it's no longer greater than 5. It's now else, or box is blue. Notice, too, to remember this, it's parentheses, parentheses, curly bracket, curly bracket. Your code inside is a semicolon. All right, remember this when we get into looping. Okay, then we can narrow expand search options. This is an and, this is an or. If Mr. D older than dirt, or it's Tuesday, he gets a deal at the Golden Corral. Think about it if I said now, excuse me, just jumping ahead there a little bit. If I said and, it would be much narrower, because it would have to be, am I older than dirt? Well, that's true. And is it Tuesday? Oh, well, that's true too. I still get a deal at a corral. But if it's not Tuesday, or I suddenly get younger, then it's not going to be true. Okay. Last thing, Boolean variables. Boolean variables either true or false. Personally, I like using flag for that. That's probably just because the way I was taught. A flag is true, then do this bit of code. Flag is now false, and then else, do this code. Flag is true. So this is a way of this is a good way of Boolean yes or no, true or false, but it's a good way to flip something. So if you wanted to alternate something, if paint the square black, flag is, let's say, Boolean flag is true. All right, then I can do something like this. If flag is true, then paint the wall white. Set flag to false. Next time through the loop, is flag false? Is flag true? No, it isn't. Go back down there. Paint the wall black. Let me try that again. Sorry, folks. Boolean logic allows you to be either yes or no, true or false, 0 or 1. So you can also do it to what I call flag or flip things. So I'm playing walls black or white. So if I say flag is true, then paint the wall white, false, paint the wall black. So if I started off with a Boolean flag, set it to false, first time through, it's going to go, oh, is it true? No, don't paint the wall white. Else, as it's not true, then make it black. You paint it black, you made flag true now, it comes back up. If flag is true, then paint the wall white and go back and forth if you wanted to checkerboard in your loop. I guess is the way I was thinking of that. Okay. Now, we did these conditional statements in processing, and we looked at it. If mouse width is greater than mouse 2, we made this bright, we made those dim. We also did a really important part. If we put our mouse over this thing, it will get really bright or really dark, as you saw. Then, same thing, a lot of if-then statements. If this is true, if this, but it's constrained. That says keep your values between 0 and 255. R, G, and B have to stay within. It can red can never go any greater or less. All right. And then we talked about, here's an if statement. If mouse is 100, if mouse is 200, strike 200. If we ran the program, remember we got a red and green. That the minute you moved over, the red stayed up, the green stayed there. Then we went and said, well, we did an else if mouse greater than red, else if greater than 200. And what that did is it would loop back through. So when you started here, it would be red. Moved over here, it would be green. The red would go away. Why? Because it would test for red and then go back and redo the background back to 0 and then come back and retest. It's constantly looping through. When you got to 200, it would paint it green. Order that matters. Now, and this one is probably the most best way of doing this. The order matters a lot. If mouse is 300, we drew a screw out. Listen to me. We drew a blue rectangle here. If mouse was 200, we drew a kind of a red, red rectangle here. Trying to get my colors right. Yeah, excuse me. A green rectangle here. Excuse me. Then if we had the mouse pointer over here, it drew a red rectangle. All right. And if it was else, it would have drawn any other color. These lines were just here. So just again, if you look at the code, greater than 300, mouse X, so out here somewhere, so 300, there's your fill, so that would have been blue. 200, the fill would have been green. 100, the fill would have been red, as you saw up there. And this showed us the and. If mouse X is less than 240 and mouse Y is less than 135, do this rectangle. And we just did variations all the way down. It shows you the and symbol. Okay. And this one did the or. And this is the ball. We got it to go across the highway. I hope you're able to figure out how to go up and down. So most people did. Good job. And that was the homework. All right. And then we did pretty cool location of square, and this is the one that we started doing for the rectangle running around the circle. I saw people send me nice videos of their rectangle, and it followed this trail all the way across. Over here. What you did is it checked states. Wherever the state was, you started changing that state, and you could sit there and play with it. And you could tell it to either go in the X or Y direction depending on what state it was in. So if it was up here and this was state 0, you told it to go in the X direction, right? And just kept moving over this way. Then you told it in state 1 to go in the Y direction, state 2 back in the X direction, state 3 back in the Y direction. And hopefully you were able to figure out how to change color on that. Most of you did. Gravity was just cool because it's gravity. What can I say? And we, it bounced up and down. you know, it's kind of a cool center, x, y, 0. If height multiply instead of 9, 1 slows the square down each time it bounces. If it was greater than gravity, it would keep bouncing up higher and higher and higher. This is a face thing that another student did that I thought was cool. But I want to go down here to what we're doing today. If you think about it, now we're going to talk about processing loops. And in the next few minutes, I'm going to go through this, show you basically a while and for loop, and then I'm going to have you write two programs, and that's going to be your homework. So I just, again, there's going to be two programs at the end of this. Oh, by the way, and I'll mention this again at the end. If you haven't already signed up at what time I'm supposed to see you today or tomorrow, please do. We need to get that rocking. Thanks. If lines of code, while lines of code. If you look at an if-then statement, it's if this is true, then do this. A while loop really works the same way. If it is, do this. The difference is the if statement will do it just once. If there is no loop in this if statement, it'll test it once and that's it. This will continuously loop and loop and loop and do it over and over again. Okay? So that's the difference between an if statement. Now, most of the if statements, we put them inside a draw loop, so it kept repeating. But if you didn't have it in a draw loop, you just had an if bit line of code that would do it only once. Where a while does it until those conditions are met. Or no longer true, I should say. All right? So we have this. The reason these if statements worked over and over again, because you're saying, well, Mr. Dubik, we did an if, it's kept running, because we have it in this draw function right there, which is a version of a loop, kind of like a Boyd loop on Arduino. So for the rest of this lesson, we'll not be using the draw function so we can better understand how while and for loops work. So no draw right here, because I don't want you to see something. All right, so while this is true, do a line of code. So that's a while loop. You've got to be careful that you have an exit condition. See the exit condition? 5 greater than 4. This would never leave. 5 is always greater than 4. You wouldn't even really do this kind of loop. You could, but it doesn't make sense because it's always going to be true. The code's, it's never going to get out. It's going to be a forever loop. It's called an infinite loop. Generally a bad thing. Yes, I know in Arduino programs where we tend to get a loop going and staying in there, but generally infinite loops are not good. Okay? Now, a for loop, I'm using, oftentimes you'll see I for integer. I don't like doing that. I like using a variable that makes sense to me. The variable I'm using here is counter. Counter equals 0. Counter less than 100. Counter plus 1. What this is saying start counter at that variable at 0. So think of this as defining the variable at 0. Counter is less than 100, and you might have defined it as a global variable. It could be this too. Let me add this in here. Integer counter is 0, so you're defining the variable, setting it to 0. Do this until counter hits. Do this while counter is less than 100. Increase counter by 1 every time. This is shorthand of counter equals counter plus 1. They just do counter 1. Do your lines of code. Okay? And I think of for loops as counters almost always, for the most part. So that's why I like the variable counter for. All right? Now, all right, I've got two programs that are going to come back here in a minute to get to your homework, but I want to run some code so we can see what we're talking about. I'm going to explain it that way as well. So let's look at it again. Let's go under my sketchbook. Let's go down here. Okay, so if I run this, size, color mode, HSB, this gives you a hue, saturation, and background. That's, I just wanted you to see that, and it looks like this. It's a little more solar thing. Well, really not doing a whole lot here. Looking at it going, well, what the heck? That's not much of a deal. So let's bring up the next program. because all we've done is done the color. We haven't drawn anything out. That's what's missing. In case you're going, well, look, that's a new color every time. That's pretty. Anyway, see how it comes up in different hues? So if you just want a different color background, there you go. Now, I'm going to bring up the next one. And it was loop 1. Let's go to for loop here. What's a great irony is it's a while loop, but as I'm going with this. But here we go. Now we're drawing an ellipse, in this case a circle. Again, random background. Look. Hue, saturation, and brightness. HB, I think I said background last time. HSB, brightness. We're not using red, green, and blue because we used it all the time. That's the only reason why I tried it. Just wanted something. Here's random 255, random 50 to 100, random 50 to 100, give you your background, no fill, stroke 25 by 0. What no fill does, by the way, let's re-mention that. No fill says don't fill up, if it's a rectangle, don't fill it up in the center, like we did in Inkscape or Corel Draw. Stroke is the outside line. There's a no stroke command and just a fill command, so you can go back and forth. So here's our ellipse. 100 by 100 size, starts at XY 100, 100. Here we go. And every time the background will be a little bit better, there's our circle. All right. Now, let's go to for 3. Hopefully. And I'll give you a second. Wait a minute. Let's get you to this point here. All right. I'm going to count to 3. 1, 1001, 1002, 1003. All right. Now, so that's what it looks like. And you don't worry, the background color is going to be different every time because of the random. See, background, random, random, random. You have more questions about hue, saturation, and brightness. You know where to look. That's color mode, HSB. Wow, hue, saturation, and brightness. You can look under the reference. All right, let's go here. Now, we're getting multiple circles. All right. And that's why, but you're right, ellipse 100, ellipse, 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 ellipse. That's going to get old after a while. All right. It really is going to get old. And so that's why it does this. And the reason we don't use fill here is it's not always obvious. I'm going to put a fill in here just to show you can see this. I'm going to make it 254. Could have been 255, but watch what happens now. Fill, let me see here. Oh, well, don't make it a capital F, Mr. Dubik. All right, now it's the right color. Let's do it. And see, it looks like a blob. This is with the fill on. I'm going to turn fill back off. I'm going to go to tell it no fill. You can't just turn it back off. You're going to say, hey, no fill. No fill. Whoops. Oh, I did that, but I didn't. Make sure it's blue again, because in that case I didn't capitalize it. And now we'll run it. There it is. So that explains why you can't. It doesn't get a cool thing. But this would get old really fast. We've learned from programming in the past, we don't want to repeat code, so we're going to use a loop. This is going to say, again, and I'm going to say counter is a counter here, but we'll call it a while. While counters less than 360. Go ahead and make this loop over and over again. Watch what happens. There it is. All right. Now, what I do want to do is I want to make, I'm going to go ahead and change this over here. This. Right. There it is, a little more clear on me. All right, so we've got it set there on color on it. We've got a counter less than 360. It's going to go ahead and change it. If you wanted to be random, you could have done this. You could have said stroke. random 2 52. Watch this. Doesn't really show it very well. Not on this drawing anyways. So it's just going to go through a shade of gray from 0 to 255. I don't know if we can see it enough with this contrast to make a difference. We could try. All right. So now let's go back to 255. I don't like it. Let's go back to what that is. Back here. There we go. So I'm going to go ahead and stop and give you a minute to play with this. So go ahead, write this code. It's really, you're just going to add this while loop in here. And let's go through one more time, explain it. While the counter is less than 360, make an ellipse counter. So that's going to put it, as this loops through, it's going to be at a new X location every time. So counter starts at 0, 0, plus 20 is 20, 100, 100, 100. Counter, add 20. Back up here is counter now 40, 40 less than 360, and you just keep working your way through, which becomes 60, and it keeps alternating up. And you could play with this. You know, you could decide how much you want to have this increase every time by changing this. Let's see what happens if we do this. They're farther apart even more so. Let's do this. All right, so you can start really messing around with this over and over again, and I would encourage you to do it. Heck, that's half the time I discover something in programming, is just playing around and changing a few things. All right. Okay, here's even an extreme version of this. Look how cool that looks. All right. So here we go. Like we just mentioned a minute, you got while counter 360, ellipse counter, counter plus 2, 100, 100, counter equals counter plus 1. So now we're just going up one at a time. We're making the circles real loose. It's very tight. Go ahead and try that one and experiment with it a little bit. All right. Okay, here's another one. Ooh, that looks funky. So save that. So what I would suggest is go ahead and try, make a change here. I'm going to give you, in each case, we change the X and Y, start changing the size. It's kind of cool. We're going to give you 3 seconds to do that. 3 seconds to pause, and you come back to it. Ready? All right. Now, same kind of loop. Let's try what this looks like. Again, it's stunning the loop a little bit. So at this point, take a few moments just to play with the different variables. Try to use variables in here as you do it. Change, mess around a little bit. All right. 1, 2, 3. Can you make it go up and down? Bounce to the ground and bounce back up? It's not homework or anything, just curious. See if anybody wants up for a challenge. All right, I think that's back to loop 1 where we were. All right. What I meant by a challenge, just so in case. Oops. Could you figure out a way so it hits here and then bounces up there? That would be quite a challenge and involve some if-then statements and things. Not assigning that for homework. Don't flip out. You don't have to do that. But I'm going to show you what you're going to do next for your homework. All right. We are going to now, these are all while loops. And now what I'm going to do is go to loop 11 here. Oops, that's not what I wanted. All right, look at this bad boy. Whoa, crazy time. That's what it looks like. So let's go through this code here. Now I am using some code. All right, so now I went to the variables. So x is 0 because this is the x-axis. X is less than the width. Print x. Integer y 0 while y is the height. So x and y. So that's why those got trumps. You've got no stroke on this. Fill random 255. All right, then you do x and y. There's your x and there's your y, and that's exactly what those are, and that's how we ended up. I will give you, this is a while loop, and inside of it, we have another while loop. There's our embedded loops. You can loop embedded and watch what happens. And if you look down here on this, you're going to see, notice the outer loop keeps saying 350, but the inner loop keeps getting faster and faster. So what happens is this goes once, this goes 255 times. This goes to the next one with a while. This one goes under 255. So you can embed while loops that way. All right? So while's out here, one time, then inside 255 times. Why do I know that? As we get through here, or I should say not 250, 400 times. That's 400, excuse me. So y is less than, x less than 400, it is. It goes down this loop. This says y less than 400, yes, do it. Do that loop again, then do that loop again, do that loop again, get to 400, then go up to there. Now you're at 2. And that's why you see 350 stays, the outer loop stays at 350, the inner loop is going up by 10 each time. All right, so we have that. Notice no stroke, so there's no lines in between it. If I did stroke, we'll run it real quick here. If I did stroke, let's do 5. There's lines. See how we have a grid now? It'll really pop up when I do this, I think. Or look a little bit better, maybe. I make no promises. Yeah, there it is. See, the grid's a little clearer. But if you don't want the grid, do what we just taught you. So then we get to no stroke. All right, and then there's no grid. Okay, now we're going to do one more. And this is a for loop. Now, what I'm going to do is actually, I'm just going to review again. Since we really didn't do a for loop before, I want to go through here. So here's your float, red, green, blue. Those could be integer just as well. With a for loop, for integer x. So again, I'm using x and y here because we're talking the x and y pixel coordinates on pixel. All right, for integer x, start at 0. Is it less than the width? And in this case, that's 255. If so, add 10 to it. And do whatever inside that loop. Now, I've embedded this loop as well. But I'm going to tell you what, I'm going to comment it out. So just imagine it was one loop. So just imagine that inner loop's gone. Let's run it once. Oh, and of course it just told me it didn't like that because I'm using the y there. Okay, we're going to make blue. I'm just going to add these on here for right now. So it's taking little dots going across here. That's one loop. And what the loop is, for integer x. And in here, honestly, I like counter, so let's use what Mr. Dubik generally does. For counter, you might do something like that. Increase counter by 10. I'm going to undo all these in a minute. Just drive home this whole loop thing. It's a counter. It's counter less than width. Width is 255. Add 10 to it. Then do this code down here. So you got it. We would need to make this counter. All right. And then counter here. There it is again. All right. It runs the whole loop and goes back up. So again. All right. Now I'm going to do command. All right, here we go. I'm going to go back. I'm going to make it so it's all right. Now let's run it. All right. Now, when we had one loop, it was only do one row down. Now it's doing all the way down there as well. So that's kind of neat, in my opinion. And there we are. And you can play with that if you try. And when you have loops embedded in loops, sometimes pull that out and see what it does to change it. All right. So, and again, you could, we've got a stroke of 255. You could try the same thing. Here's what it looks like when you don't have no, I'm going to go no stroke. We'll get rid of the 255 because there's no reason. You don't need it. Now watch this. It's kind of wild. Almost looks like, what you don't realize is that's actually the circle, and that's the white that's not filling in on the background, which is kind of crazy. All right, so that's no stroke. All right. Let's go back to stroke. For me, anyways, I find I have to experiment to see if I get the look I want. I always ask, because I've changed that function back, it's always stuck. So there's the circles back. Okay? Now, all right. So, I've showed you the video. Make sure you've taken some moments to do this. Play with it. Make sure it sets, because here's your 2 questions. This is your homework. You saw how we made that. Make this. Please program the and use a while loop to do this. And I'm guessing you figured out you're probably using some embedded loops here. Please program the color image above using shades of gray. The image is a start. Hint. Notice how the red and green seem to increase as you go down the square. Stroke function plays a role here as well. Please use a while loop when you do that. When you send me a picture that you got it working and the code with it so I can look at your code. Second one, the other piece of homework. You've got this, make this. Again, use a for loop on this one. Use this as your example. How would you change it so it changes the other way? Again, send me your code. That's your homework. Remember, you signed up on a spreadsheet I shared with you yesterday. I'd like to see everybody. Unless you're seeing my advanced class, we're going to see as a group today. So, with that in mind, have yourself a great day. Thank you. Bye-bye.